Hi, today I am going to derive the Lagrangian equation of one-dimensional harmonic oscillator. So our question is, find the equation of motion of a one-dimensional linear harmonic oscillator using Lagrangian dynamics and also find its frequency of oscillations. So the Lagrange equation of motion can be written as d by dt dou L by dou Qj dot minus dou L by dou Qj equal to 0, and this is a second order time dependent differential equation. The generalized coordinate, that is Qj equal to x, and the Lagrange function L equal to T minus V, that is kinetic energy minus potential energy. The basic figure of a spring due to elongation can be drawn here, that is x is the elongated length of the spring when it is loaded with a mass m, and T equal to half mv square, which can be written as half m x dot square, and x dot is the generalized velocity. This is equation number 1. By Hooke's law, we know that F equal to minus kx, and we also know that F equal to minus del V from electrodynamics, and this equation can be written as F equal to minus dV by dx, and v equal to minus integral of f dot dx, and v can be written as minus integral of substituting the value of f from this equation, that is minus kx and dx, which is equal to kx square by 2 equal to half kx square, and the value of v equal to half kx square, and this is equation number 2. L Lagrangian L equal to T minus V, that is L equal to half m x dot square minus half kx square. This can be obtained by substituting the value of kinetic energy and potential energy. The Lagrangian equation in terms of generalized coordinate can be written as d by dt dou L by dou x dot minus dou L by dou x equal to 0, which can be marked as A, and this equation is obtained from the Lagrange equation of motion we written earlier, that is d by dt dou L by dou Qj dot minus dou L by dou Qj equal to 0. By finding the differential of each values, we get the Lagrange equation, that is dou L by dou x dot equal to half m 2x dot minus 0 equal to mx dot. The value of L is half mx dot square minus half kx square, which we earlier written, and d by dt dou L by dou x dot minus dou L by dou x equal to 0 is the Lagrange equation. Taking only this term dou L by dou x dot and partially differentiating L with respect to x dot, that is partially differentiating L with respect to x dot, we get half m 2x dot minus 0 equal to mx dot, and dou L by dou x, that is dou L by dou x equal to 0 minus kx equal to minus kx. This is obtained by partially differentiating L with respect to x. At last, d by dt dou L by dou x dot equal to d by dt mx dot equal to mx double dot. Substituting in A, that is in this equation, we get mx double dot plus kx equal to 0. This equation can be also written as x double dot plus k by m x equal to 0. Differential equation for a harmonic oscillator is d square x by dt square plus omega square x equal to 0. And comparing equation B and equation C, we can write that omega equal to root of k by m, and we also know that omega equal to 2 pi nu, and comparing these two equation we get 2 pi nu equal to root of k by m, and from here nu equal to 1 by 2 pi root of k by m, and this is the frequency of oscillations, and m x double dot plus k is equal to 0, also x double dot plus k by m is equal to 0 is a Lagrangian equation of one dimensional harmonic oscillator. Thanks.